Imagine taking a bite of your favorite food. What happens next? The journey of digestion, a fascinating and intricate process, kicks off right in your mouth. Chewing, often taken for granted, is the crucial first step. It mechanically breaks down food into smaller pieces, increasing their surface area. This makes it easier for digestive enzymes to work their magic, but chewing is only half the story. As you chew, your salivary glands release saliva, a watery fluid that mixes with the food. Saliva isn't just there to lubricate your food and make swallowing easier. It also contains an enzyme called amylase. Amylase starts breaking down carbohydrates, complex sugars found in many foods, into simpler sugars. This mixture of chewed food and saliva is called a bolus. Once formed, the tongue, a muscular organ in your mouth, propels the bolus towards the back of your throat, initiating the process of swallowing. This act is the bridge between the first stage of digestion in the mouth and the next stage, the journey down the esophagus. From the moment you take a bite, your mouth is a flurry of activity, mechanically and chemically breaking down food, setting the stage for the remarkable journey ahead. Swallowing might seem like a simple action, but it's a carefully coordinated process. Once the bolus reaches the back of your throat, it enters the esophagus, a muscular tube connecting your mouth to your stomach. Think of the esophagus as a dedicated food highway. Unlike the mouth, the esophagus doesn't actively break down food. Its main job is transportation, ensuring the safe delivery of the bolus to the stomach. This transport is achieved through a wave-like muscular contraction called peristalsis. These contractions, alternating between relaxation and constriction, propel the bolus down the esophagus. It's like gently squeezing a tube of toothpaste from the bottom to get the paste out. This rhythmic squeezing action ensures the food moves in one direction, towards the stomach. The journey through the esophagus is relatively quick, taking about 10 seconds for the bolus to reach its destination. Once it reaches the end of the esophagus, a muscular valve called the lower esophageal sphincter relaxes, allowing the bolus to enter the stomach. With the bolus safely delivered, the stomach takes over the next stage of the digestive process. The stomach, a J-shaped muscular sac, is often considered the workhorse of the digestive system. Here, the bolus encounters a highly acidic environment, a far cry from the neutrality of the mouth. The stomach walls are lined with glands that secrete gastric juices, creating a churning acidic pool. This potent concoction is crucial for breaking down food further. Gastric juice contains hydrochloric acid, responsible for the stomach's acidity. This acid helps kill harmful bacteria that might have been ingested with the food. In addition to hydrochloric acid, gastric juice contains enzymes like pepsin. Pepsin breaks down proteins, one of the major building blocks of food, into smaller units called peptides. As the stomach churns and mixes the bolus with gastric juices, it transforms the partially digested food into a thick, soupy mixture called chyme. This churning is essential for ensuring the food is thoroughly mixed with digestive enzymes, maximizing their effectiveness. The stomach doesn't just break down food, it also acts as a temporary storage unit. The chyme remains in the stomach for several hours, allowing for optimal digestion before it moves on to the next stage in the small intestine. Section 4. Small intestine's grand absorption spectacle nutrient uptake. The small intestine, over 20 feet long, is where nutrient absorption takes center stage. Chyme enters the small intestine, ready for nutrient absorption. The lining, covered in villi and microvilli, increases surface area for absorption. Pancreatic juices and bile aid digestion, breaking down nutrients for absorption. Nutrients pass into the bloodstream, fueling the body. Section 5. Waste not, want not, the large intestine and beyond. By the time the chyme reaches the large intestine, most nutrients are absorbed. The large intestine focuses on water reabsorption and waste elimination. Indigestible material, mostly fiber and water, moves through. Water is absorbed, solidifying waste into feces. Gut bacteria break down carbohydrates and produce vitamins. Feces move to the rectum, stored until a bowel movement. During a bowel movement, feces exit the body. This journey showcases the body's efficient design,